Hello and welcome to MongoDB Podcast Live. I'm Shane McAllister. I'm one of the leads on the developer relations team here at MongoDB. Imagine dealing with 11 million land documents, historical records, contracts, leases, all scattered across different formats and different systems. The challenge is making sense of all that unstructured data efficiently without sinking of millions of dollars into manual processing. That's where AI and large language models and MongoDB come into play. So let's get started. And to discuss all of this, I'm really pleased to welcome Alex and Andrew from Oxy.com onto the show and to unpack how they did this and why they chose MongoDB and what it means to the future of AI-powered document management. Alex, Andrew, you're both very welcome to the show. It's great to have you.
Thanks, Shane, for having us on. Thanks to you and MongoDB for having us in.
No, it's great. It's great to have both of you join. It's great, as I said, when we were preparing, to have you both in the same room. It's always much easier to deal with two guests in that regard. Before we get started, I love that we have both of you here. Could you pick Andrew or Alex to go first to talk a little bit about your career path to date? What you studied, how you got here, and how you ended up at Oxy.
Let's kick off.
Sure. Yeah, I actually started at Oxy probably 10 years ago, just about 11 years ago. Undergrad, I did petroleum engineering at the University of Texas at Austin. And pretty early on in my career, I went more towards data and less towards kind of the traditional petroleum reservoir production engineer of oil and gas. And so I kind of managed data for most of my career. About 6 or 7 years ago, I did a master's in computer science, just because I felt like that was really where my interest was. And then since then, it's been kind of a journey. I've done a little bit of more like embedded systems, microcontroller stuff. And then a couple of years ago, I joined Alex's team, and Alex runs the AI team here at Oxy, and I'll let him take over.
Yeah, excellent. Sure. So much like Andrew, I'm kind of the confused engineer / data scientist archetype where, majored in petroleum engineering at University of Tulsa, and then ended up working for Oxy in 2017 and increasingly got more in these data-focused, AI-focused roles. So, yeah, now the team that Andrew and I work on, it's an ops-focused AI development team at Oxy, and we get to have a lot of fun with applications, mainly on the oil and gas kind of production side of things, but occasionally dabbling with other departments like legal or land in this case that we're sharing today. So, yeah, excited to share the work. I think the AI space, people disagree about whether it's overhyped, underhyped, but I'll just say this: it's a lot of fun to work in. So we've been having a good time the last year or two.
Excellent. Thank you, Alex. And I suppose, look, before we dive into that and the problem that you're solving and the reason why you're on the show here today, I suppose people consider the oil and gas industries as, heavy industries, large machineries, large refineries, distribution, all of that sort of stuff. They wouldn't particularly maybe think of it as using data, et cetera, bar where to drill or what to do or minerals or geological surveys, et cetera. Tell us a little bit about the Oxy as a company and what it does, and I suppose the industry as a whole, and how it's using digital these days before we dive into the specific solution that you built.
Maybe I'll take a quick pass and then Andrew, you fill in what I missed. But I'll just say, oil and gas has always been, technology's been really important in oil and gas, especially you look at the history of seismic data processing, and some of the original large scale data processing projects were hugely seismic focused. So Oxy in particular has taken a really aggressive stance towards innovation and AI in general. So there's a couple fronts. One is Oxy has, I think, the most aggressive direct air capture effort of any oil and gas company right now. So obviously that's out of scope for our talk today, but if you check on the website Oxy.com, you'll see some really phenomenal work happening in the technology space there. And then second, with AI, Oxy's been really bold with in terms of its aggressiveness with applying AI. I think our team, some of the work we're going to share today is part of that, and obviously there's a lot of other work besides that we'd love to talk about another time. But I think Oxy and certainly I agree that AI is going to be one of the key differentiators when you look which oil companies are going to be the most successful 3 to 5 years from now. I think it's going to be the ones that were most successful in applying this to streamlining the work we do, improving the work we do, increasing safety, reducing our cost per barrel. So I think Oxy's got the right attitude towards this, and I think that kind of bears out in the work that's going on here.
Yeah, I think Alex pretty well covered it. Just more on the data front, there's a lot of data we gather. Aside from just seismic, we gather tons of SCADA data. So every single well is equipped with, I don't know, probably on average 5 to 10 sensors that are all gathering data in real time. Facilities has orders of magnitude more sensors than that, gathering data in real time. So yeah, I think the amount of information being captured is often underestimated. And then if you get into drilling, it's like just massive amounts of data for any given well that you drill. So yeah, oil and gas, I don't think they're a stranger to large quantities of data. I think they've traditionally been viewed as maybe definitely not on the the frontier of tech, but there's a lot they do that might surprise you.
Excellent. And look, I know we're going to delve into that as well too. And thanks for everybody who has joined us on the stream as well. We see from folks from Minneapolis and Pakistan, etc. And Jeff gives you a shout out there, Alex, Jeff Schmidt, who obviously you know. So look, it's great to have everybody join us as well too. Size and scale of Oxy as a company. How big is the company, and how big is kind of the AI team that you guys are working on?
Sure. So, I mean, first, Oxy's been around for over 100 years now. Oxy's got quite a history of international operations. I couldn't even count how many countries. I think today we operate in maybe five or so countries. Don't quote me on that. Roughly 5 or so countries. But in terms of scale, 15,000 employees or thereabouts. It's a large Fortune 100 company, significant oil and gas presence, especially these days in the Permian Basin, Gulf of Mexico, and DJ Basin in the Rockies. So, yeah, Andrew, anything?
Yeah, as far as production, if you're familiar with it, we're about 1.4 to 1.5 million BOE per day. Are we the biggest Permian producer?
Yeah, we're either close to or the biggest
first or second Permian operator.
Okay.
So yeah, we do a lot onshore U.S.
I'll say one thing about Oxy. I think for those that are joining that are outside of oil and gas, I think the oil companies we know about are the ones that we buy our gasoline from. And so a lot of the times Oxy doesn't do that, right? There's no downstream refining, selling to the customers. So I think that kind of reduces our public presence for those outside of the industry, unless they happen to attend an Astros game, in which case you can't miss the Oxy logo on the field there. But yeah, that's a little bit about Oxy.
So Oxy's big enough to be a team sponsor then. So that's a good bracket to put things into as well too. And I appreciate you, Alex, not courting controversy there and calling it the Gulf of America. You called it the Gulf of America.
Goodness.
So let's
leave that aside. I didn't even think about it.
Perfect. And listen to the others that are joining us from Spain and from India as well too. It's great to have you all on board. So look, at the beginning I said, in the introduction, I talked about 11 million documents, etc. Can you walk us through kind of the challenge that you were faced? When did this start? When, everybody kind of considers, the public per se considers, AI and Gen AI and large language models having been born in November 22 when ChatGPT came out to the public, but obviously it's been around for a long, long time. So tell me a little bit about the pre-solution that you have. What did that look like for the folks at Oxy for all of these documents they have, before we get into kind of your approach to remedying that and make it easier for them?
Yeah, this might be a good chance to share kind of a visual, because I come on a Mongo podcast and I talk to you about our document problems, and you might be thinking of something different than what I'm actually talking about. So you might be thinking of this kind of document, right?
Yes, yeah. Really, we know what documents are here, but they're not the documents you're dealing with.
But right. So no, the documents we're here to talk about is actually it's this kind of document. So it's, a
Okay.
PDF, a scan, a paper document. So like I said, Oxy's been around for over 100 years. So we've accumulated quite a lot of documents, paper documents. And some of them look like this. This one's pretty easy on the eyes. It's just a classic lease agreement. But then I might show you this one.
Oh, wow.
A bit older, a bit harder to read, a bit crusty looking maybe. And then I could show you some other examples like this, or this. So getting a little bit harder, right? Or this, or this, or this one's one of my favorites. I like how the hand actually made it into the scan.
An important part of the scan, yes, definitely. Oh wow, okay.
And then you get the sense
in boxes.
we actually have a lot of these. So this is one kind of row of, I think there's maybe 40 of them in this particular file room, and there's a dozen or so file rooms. And then a fun, that's me at the end of the hall there, and I'm short, but I'm not that short. It's a lot of documents, suffice to say. So kind of laying the groundwork. Obviously, Oxy isn't unique in this. Every oil and gas company that's been around for decades or 100 years has vast troves of documents. The ones that we're talking about today pertain to land, which is the process of leasing minerals and understanding the ownership of minerals and rights throughout time. So land is not the only part of the oil and gas industry that's very document heavy, but it's one of the very important parts. And throughout the years, Oxy's undertaken a number of digitization efforts. So that's scanning in. It's very rare that somebody's going and actually handling a paper document these days, as you would hope. These have been digitized, but even once they're digitized, there's a lot of additional work that needs to follow after that. And so what Andrew and I found out about last year was an effort to digitize, or rather, they'd already been digitized, but there was some additional work post-digitization happening on 1.5 million land documents. So the idea here is, we have these scanned in, and we know, okay, for this lease agreement, we have maybe 100 or 150 documents that pertain to it. But if I'm working in the land department and I'm asked a question about a lease, it's not enough to go say, hey, here's 150 documents that govern this lease. I would like to know which document is which type. I would like to know some of the metadata inside those documents without having to open up each of those 150 documents. So you can imagine it's really useful to be able to categorize documents and extract information out of them. And
I would imagine that process originally, even the scanning obviously is labor and time intensive and resource intensive. But as you say, then having to look these up, etc., obviously, again, time and resource intensive.
You can imagine for 1.5 million documents, for someone to go in and categorize it and then to extract maybe 5 or 6 pieces of information out of that document, that's going to take a long time. And that's exactly the project that we walked into last year. Andrew and me and one other gentleman on the team, Eric, we learned of this effort to manually categorize and extract information out of 1.5 million land documents. So that was going to be done with a small army of contract workers.
Wow.
So yeah, I think 40 people were scoped onto this project. It was to take 1.5 years. And so the you can imagine the cost associated with that. And there are also a lot of tough decisions you have to make when you're having an army of non-expert contract workers doing a task like this. The scope of the project has to be very limited. For example, I mentioned categorization. We want to categorize what type of documents these are. When we're doing this manually and we're paying by the hour for the work to do this, we had massively limited, the land department had massively limited the scope of this effort to just 6 different categories. So very broad stroke, broad cut categories.
Okay.
And then when we talk about extracting some of the information from inside these documents, similarly, they had limited it to just the most basic facts and figures, dates, things that were easy for a non-expert to pick up and pull out of these documents, but ones that would nonetheless help the land team as they're working with these documents into the future. So not only were we dealing with a very expensive project, a very long duration project, 18 months, it was also going to be a very tight, narrow, limited scope for the purpose of cost savings. And so that was kind of the scene where Andrew and I early last year, were looking at each other and we said, man, isn't this a perfect perfect project for a large language model.
So timing was on your side there, I suppose. You're getting in at the ground roots of a project and seeing whether, I suppose, and we'll talk a little bit about this, obviously, is your approach, how did that compare to the approach that the pathway was already indicating? Lots of people, long time span, and only actually a constraint of only getting some of that information out of those documents, right?
Yeah, I think first, Andrew and I were no strangers to language models. We had done some work on them with them at Oxy already. I think all the work we had done before was obviously a much smaller scale. So that was a bit what scared us about this. Not so much could we do it. We were pretty confident that this is possible, but to do it at a larger scale, and the data management practices that would require, and just the cloud resources that would require, those were some of the things that we were a little less confident in. So we wanted to very quickly de-risk this and understand, first of all, prove out, can we do this? Because this other team is going to take on this project, do this manually, contract this out. It's already been budgeted. The year's underway. The project's about to start, just a month and a half away. So the question is, first of all, can we prove that we can do it? Can we convince people, wait, stop what you're going to do. Let's do this instead. So that was our challenge. And so we set out.
Was that a proof of concept for you then? Did you had that short window? You had 4 weeks, 6 weeks to be able to show that this would work?
Close to 6 weeks. Wow. That's exactly right. We wanted to do a proof of concept. So we took some of the a subset of the documents, 1,000 of the documents, and we set out to do, again, there's 2 tasks here: classifying and extracting. And just to back up, we looked at a lot of those documents. You get a sense that, some of these are easier to read, some of these are harder to read. But one of the most important things we had to do before we could even do the classification and extraction was figure out OCR, optical character recognition. And OCR, people don't think about it as AI, but it actually somewhat is. It's kind of depending on how you define AI, that is a form of AI, and it's a really important prerequisite step here. Traditionally, Oxy had used a vendor, Kofax, for our OCR. And you can see with this particular document, it really struggled. You can see Atlantic operating turned into Atlantic gyrating. Which, while it's kind of funny, we don't want that to make it into our land database down the road.
Sure.
And you can see generally it struggles a lot with the handwriting here. So for the first task we had to do was benchmark a number of the different OCR providers. And I think if anybody's experimented in this space recently, it's actually changing really rapidly. I think multimodal models are increasingly being used for OCR, and the cloud vendors are improving quite rapidly their OCR solutions. The open source space is also improving rapidly, though we found a pretty big gap when we went about benchmarking all the different OCR options, open source and through cloud providers. We found the best results on our documents with Azure Document Intelligence. And that's what we ended up using for this project. And I'll say real quick why that's so important. If you imagine, if you're the large language model, if we feed in that text in the top right here, it doesn't matter how smart the language model is, it's not going to be able to fix what's broken on the input. So it's very important to get this very boring OCR step. It's important to get this right for that reason.
Yeah, and it would compound, I suppose, we accuse LLMs of being hallucinatory sometimes as well too, but if it's got fed the wrong information in the first place, we don't really know where that came from, and we're kind of, I suppose, blaming the LLM as opposed to actually the original OCR. So that was a task in hand anyway, was to get very accurate, appropriate, proper OCR. So that would have taken a good chunk of your time at this kind of tiny 6-week window, right?
Yeah, unfortunately, as you said, in this short window, we were lucky. We're dealing with a small subset, just 1,000 documents instead of 1.5 million. So we're just trying to prove the point here. So we were able to get this benchmarking done pretty quick and move on to the next task, which was classification. We talk about classification. I had teased you earlier with the scope being very narrow, just 6 categories. Well, not so lucky in our case. I think once they realized, hey, AI can maybe do this, they said, well, instead of using the 6 categories, the 40 contractors would be asked to do. Let's try expanding that scope a little bit. Let's do 140 categories. This would be much more useful.
Let's 20x that. Yeah.
Yeah. So,
Yeah.
I don't know how we got hoodwinked into that, but somehow that happened.
Yeah, you were up for a challenge. Yeah.
I will say we were really lucky for this project to have, for most of these categories, we had reliable hand-labeled data from our existing legacy records. So, this 1.5 million new documents is what we're going after. But for the older documents, we have a lot of reliably hand-labeled data. So for those that do any kind of machine learning in the audience, you might kind of see where this is going, that we can use a supervised method for the classification here.
Okay.
And so the approach we took is we use an AI model for embeddings, an off-the-shelf model. Azure OpenAI, or rather, OpenAI releases this model, Text Embedding 3 Large. You can use it through Azure OpenAI service, and those embeddings are pretty high dimensional. They're 3072 dimensions. But once you have that high dimensionality space, you can here in this visual, I've reduced it so you can just kind of see the difference between those documents. But you can also train classifiers against those, because those embeddings are just numbers, right? So
yes.
You can train a classifier. So we just trained a classifier, supervised learning on these embeddings, plus some hand curated features. And with that, we were able to achieve really, really high accuracy. We were able to achieve, depending on the exact amount of categories and how difficult the documents were, we were on the order of 95 to 97% accurate.
Wow.
And contrasting that with the non-expert contract labeling was on the order of 88 to 92% accurate. But again, that's with a much more limited subset of categories, so a much easier problem. So we were really, really pleased with the classification results.
And in the same way that
really
you,
simple.
sorry, Alex, in the same way that you had to, check out a few different OCRs to find a good one, did you have to do the same with regard to choosing the embeddings models as well too? Because there's so many to choose from. Okay, definitely these days, and even a year ago when you were getting started at this, there was still quite a lot knocking around.
Yeah, I think when we were first experimenting with this, we tried some, I don't remember when Text Embedding 3 Large came out, but
yeah, I think at the time Embedding 3 Large had just come out, and so we kind of knew this was state of the art, and it made it really easy on us.
We might have been in the middle of the POC. I don't remember. We might have been in the middle of the POC when it came out.
Yeah.
We were using it. It's one of those amazing things about working in AI right now. It's like you're doing something, you're getting this level of accuracy, and then next week a new model comes out, and it instantly, with no effort, bumps your accuracy up. So it was like one of those moments where we're like, wow, this is too easy.
Okay.
But not to say there wasn't any iteration, to your point about trying different models. Yeah, we tried different embedding models. We tried different classifiers. We did some experimentation. But I think by and large, certainly in the POC phase, most of this just worked quite well out of the box.
Brilliant. So with the extracting being, on top of its game and doing well, and with the classifications now working, was that enough with those 1,000 documents in your POC to get the thumbs up for this project as opposed to the 40 humans in a room?
That's right. So just from the classification results, there was growing confidence among the land team that this was going to be the way to go, not just because it's more accurate, but because getting so many more categories would add a lot more value to them down the road, being able to make sense of these documents. So the last thing for us then was to just prove that we could do the extractions. And with that, again, we took a very, very simple approach. We used an out-of-the-box model to do these extractions. Some of these were very simple extractions, like things like what I showed earlier, dates, counties, just very simple fields that an untrained person could catch. Some of these were more difficult, though, things like requiring interpreting some minor simple interpretation of legal clauses, like a Q clause or a cessation of production clause in a document. And actually, that was where we were a little unsure, and we were quite pleasantly surprised at what the language models could do in terms of interpreting paragraphs of text and boiling it down to just a database-friendly scalar answer that we could insert into Mongo, which I guess we'll get to in a minute. But yeah, again, off-the-shelf model, we used GPT-4o for this. And again, this was more accurate than the contractor level classifications.
Excellent. So just off the shelf, no fine tuning, nothing else with regard to the model, off-the-shelf model?
Off-the-shelf model, no fine-tuning, just a very, very elaborate prompt. This was one of the early versions of our prompt for doing some extractions. And full credit to Eric Smith on our team, who's the person that developed these prompts. He had worked as a landman prior to his role on this AI team, so he was actually quite familiar with a lot of this, and he was able to kind of translate from land to AI and back and forth to get these models working the way we needed.
Okay. So, and the prompt text is quite small. I'm sure most people can't read what's up there, but this is where the role of the clever prompt engineer comes in, being able to preface it, set the scene, ask the right type of question, and explain how you would like the result, right?
Absolutely. And I think, we could debate back and forth about if the role of a prompt engineer is a real job or not, but I'll say for Eric, it sure was.
That's another show, Alex. That's another show.
A whole episode on that, I imagine. I'll say, at least with the state of the models they are today, you can always eke out better performance with better prompting. So there's no doubt that it's a useful skill. And I think it increasingly drives, what's interesting is it increasingly drives more of the work and the power into the hands of the subject matter expert. I think there's a lot of fear about, AI is going to take away what we do for jobs. But in this case, it's the land SMEs that are most important, because they're the ones that you need to craft this kind of prompt or some of the later versions that were far more elaborate.
Oh, yeah, no, it's a very fair point, I think. And I deal a lot in MongoDB in helping the code assistants that developers use day to day being better at MongoDB tasks. And I can totally see that we do a lot of working with partners to help fine tune and to train and to give ground truths and do evaluation sets, etc. as well too. So yeah, I fully agree with you there. I don't think we're removing any jobs. I just think we're getting rid of the kind of mundane tasks, right? And bringing everything up to a higher level. And maybe I'm getting ahead of myself. Where does MongoDB fit into all of this then, Alex or Andrew?
Well, isn't that awkward? We're on a Mongo podcast, and we've hardly mentioned MongoDB yet. So I think that's where Andrew's going to come in and maybe speak to,
perfect.
So this, just kind of closing out the story here for the POC phase. We obviously had really good results on this subset, this 1,000 documents of the 1.5 million. And so we were able to make the decision between us, IT, and the land department. We were able to make the decision that, hey, let's ditch this 18-month manual, expensive project. Instead, let's try and do this with AI. And now, I came to Andrew, Eric and I came to Andrew and said, Andrew, can you help us scale this? And he was like, what have you guys done? But he'll talk a bit about how that scaling worked.
I love how you gently approach that topic. Can you take our 1,000 document sample and ramp it up to 11 million? Off you go.
I mean, how hard can it be? Right?
How hard can it be? Yeah. Andrew, how hard was it?
Yeah, it turned out it was not too bad.
Very modest.
So yeah, the slide Alex is showing. I guess some things I would note here is just originally for the 1,000 document kind of POC, we did go ahead and build out some architecture of how we would do this at scale. And that was part of the POC. It was like, okay, you don't just want to manually be running, a Python script locally, and that says that you could, process millions of documents. That's just 1,000. Obviously, we were going to need probably some cloud compute and services to do this. But yeah, to mention Mongo, I guess we actually started down the Mongo path mainly because at the time, there was a very limited amount of databases that could handle embeddings, at least properly. So I think the options were like Postgres, Mongo, and then what's that early one?
There were dedicated vector databases.
Yeah, like dedicated vector databases. Yeah, Pinecone. There's some, but we wanted to go with something more mainstream. And then between Postgres and Mongo, we were trying to move through the POC so quickly that we really didn't want to be locked down to some specific schema or design that we had worked out. because we didn't know where it was going. You know, one day Land's asking for 140 classifications. The next day, who knows what they're going to be asking for. We might need to be changing things really quickly. So we landed on Mongo, just wanted to be in the NoSQL world. And then we had talked to Peter and Robert over at MongoDB, and we're kind of, you know, trying to, I guess, warn them like, hey, you know, this is a really intensive process. We're not sure if Mongo can handle it. And it was like, yeah, this is you know, small potatoes. Don't worry about it. It'll be no problem. And so sure enough, you know, Mongo at the 1,000, of course, it was fine. And early on, we really were just doing inserts to Mongo. So what we would do is we would take the data from FileNet, which is our ECRM, and just dump that directly into S3. And this was pretty simple, just Python script, take it off one place, put it in another place. And then from there, we would run things more in parallel just through Lambda functions. So we'd have Lambda functions handling pretty much everything Alex just talked about, and just kind of steps. So, you know, go out, re-OCR the PDF. Okay, we have good OCR data. Now go out, classify it. Okay, now I have classifications. All right, using classifications and the PDF text data, let's go extract what we need to from that. And all the while, we're kind of building up this document, and then we just dump it into Mongo. And that worked pretty well for a while. For the 1,000, that was no problem. So, you know, if we're running, let's say like 100 Lambdas in parallel, and each document maybe takes a minute to classify, we're talking very low transactions hitting Mongo. Let me see if we go. Yeah. So one issue we started running into, though, was we didn't really account for a lot of the edge cases that come with when you go from 1,000 documents to 1 million plus documents. You're introduced to a whole lot of different types of documents than you would have encountered. And so we were running into things like, okay, the biggest document we saw early on was maybe, I don't know, 50 megabytes. And now we're running into a document that's like 3 gigabytes. That's going to break some stuff if you're not ready to handle it. And so, again, like, I don't know if this is the best architecture. Looking back on it, it's probably not. But what we did was every time we were kind of like timing out these Lambdas from whatever it might be, this document's really large, it's going to take 20 minutes to process. Lambda's only going to give us 15 minutes. You know, what can we do? We basically just started storing every step of the process in Mongo. So lots of reads, lots of updates. So we moved from, you know, 1 to 5 transactions a second to thousands of transactions a second, because we're just constantly hitting Mongo for either getting a current state, writing a new state, you know, finishing the doc, updating the whole doc. And I mean, it sounds bad, but it's like, I actually didn't think about Mongo the whole time we were doing it. Like, nothing went wrong. You know, it's just like this piece in our tech stack just kind of magically worked, and we didn't have to change the configuration of it. We didn't have to, you know, give Peter a call and ask him for someone to come over and take a look at what we were doing. It was really like the least of our problems. And so, yeah, it wasn't a problem at all, honestly. So, yeah.
We'll quote you on that one, Andrew. We need a quote from you to say, MongoDB is not a problem at all. It just works, or something to that effect. Definitely.
But
I'm sure our marketing team will reach out to you at that point. So, and look, obviously you touched on the fact that you didn't know the schema, and the flexible schema of the document model helped a lot. You touched on scale there as well too, etc. Was there any other, and you touched on the various types of documents, small, large, humongous documents as well too. Any other specific challenges in this architecture here that you mightn't have seen at the POC, the 1,000 documents, but then surfaced up, other than the different size and scale of the documents that you already mentioned?
Let me
think we're talking about like token throughput limitations,
Yeah.
just briefly.
Yeah,
Okay.
so like again, you have to rewind about a year or two on this and think about when the language models were really hitting cloud vendors in earnest. Everyone was starting to use them. No one had enough GPUs, and so everyone was pretty locked down on token allocations. And so at Oxy, what we did was with Azure, we basically just had a shared resource stood up where SMEs at the company who kind of knew what they were doing with AI or wanted to try some stuff, they could get an API token to this shared resource and start using OpenAI models. And
Okay.
which was fine. You know, we want people across Oxy and across domains here to test stuff. But what that caused for us is, we're trying to process documents full throttle. We're trying to use every token we got as they're coming up. And people would go run their own experiments. Maybe they're doing something else with documents that's going to be very demanding for just like they're doing their own POC. And so we started running into all sorts of rate limiting issues very randomly throughout the day. Maybe 3 times a day, we get 429s for 20 minutes, and then they'd magically go away. And we realized what was happening was other people were trying stuff. And so we couldn't really just hard code like, some nice, like perfect amount of lambdas to be running to where we never ran into token issues. So the other thing we would do is just like, if a lambda failed on calling an Azure resource, that was totally fine. We weren't going to lose any progress because we were just storing everything in Mongo as it was our state machine. So that's kind of what we did, and that worked really well.
And what I'll call out is like we're a AI/engineering kind of team. We're not a software team. We're not a database team. So I think where Mongo really worked well for us here was it made it very easy to take this transition from, okay, we have a working POC. How do we scale that up? And each step along the way, you're finding new problems and you're having to bolt on new solutions and new workarounds or handle edge cases. And just because of the flexibility and kind of effortlessness of Mongo that what Andrew was saying before, it was very, very simple for us to go through this scaling process without having to do a total rewrite or start from scratch or really do some major work. It just made it very, very effortless. So I think for us, kind of from that perspective of an AI team that's trying to move fast and change things on the fly, it was the perfect thing for us to use in this case.
Excellent. Well, yeah, you're saying all the good things about MongoDB. I haven't prompted you at all. It's all.
I'm not gonna get a marketing phone call afterward. Yeah.
Yes. No. It's all good, and it's obviously MongoDB is cross cloud, but you're combining Azure and AWS technologies here as well. Was there any in that kind of transform and loops and everything else involved here? Any issues in that space at all, or just as with everything else was just working fine, scaling up from that POC?
Honestly, the only challenges here as far as cross cloud and stuff like that was probably more internal to Oxy. Like basically Mongo is a marketplace app instead of just native AWS service. And so we did have to go through a couple things in supply chain to kind of iron that out and be able to use our own Mongo instance. But that was very, not a big deal.
Okay. Yeah, I think for most of the AI work that we do, that if you ever see cross cloud, you kind of scratch your head and you think maybe that's going to cause some trouble. But generally, if we're working with text, like a lot of heavy text data in most of these applications, and really the amount of data you're sending back and forth, since it's mostly text, it ends up being pretty small and not causing a huge issue. There are certainly use cases that are like video or image driven where you might want to stay better within the constraints of one cloud ecosystem. But for this, it ended up not being an issue.
Okay, great. And just for our audience joining us, if you have any questions for Andrew or Alex or anything on the solution that they've built, drop them in the chat and we'll try and take care of them as we talk through a bit more. So what stage are we at here now, or what state, like, have you scanned and extracted and classified everything that Oxy have now? Is that the case? And is it the case that this architecture that you have up here is just invoked as you sign a new agreement or lease somewhere?
So speaking to this 1.5 million that was like the original project scope, that finished. Andrew, do you want to talk to kind of how this architecture kind of helps us moving forward to other document projects, some of which we've worked with?
Yeah. So I'd say for one thing is, I think Alex mentioned early on, LAN's not the only spot in Oxy that has lots of things like PDF agreements. I mean, every company, think of like HR, legal, supply chain, you've got all these agreements, PDFs, contracts, whatnot. So we actually did have a project with legal where they had some needs for OCRing, extracting, classifying many PDFs. And they had gotten wind of what we did here with land. And we were approached by them, and they're about to do the same thing. You know, let's bring on a team to help us process all these documents. And we basically just dragged and dropped this thing onto the legal documents. Brilliant. And, you know, updated the prompts, a couple things there, but like it was a very low friction, quick solution. So where this might have taken, I don't know, 6 months from start to finish, the legal one took about 6 weeks.
No, it was 2 weeks.
Oh, 2 weeks.
Well, technically 3 weeks, but 1 week was waiting for feedback from the legal team.
So,
wow. Okay.
So we've seen use cases there. And then on the, to answer your question more on like, you know, what are we doing for all documents across Oxy? I think this did churn up a lot of interest in saying, okay, there is a way we can take all these documents we have in FileNet, which is a massive amount, and maybe we can start the process of getting good OCR, extracting useful metadata, just on a very general scale of how we can classify those documents, and sort of rework Oxy's whole document foundation into something more up to date. So I think that's being explored. That's a much larger scope.
And I'll say we're being a little bit vague here on purpose with what we're allowed to talk about on some of these upcoming projects, but or ongoing projects. But yeah, suffice to say, I think the core capability here of classifying and extracting information from documents is super scalable to many different applications. And I think where we see, I think this, everybody tries, I'm not trying to start a fight, but I think everybody tries with their AI project. The first thing everybody tries is like a chatbot or a RAG-based application. And everybody goes straight to like the harder projects. And if I'm going to make one suggestion to anybody dabbling with AI and looking for internal applications, it is start simple. Start with just classification, just extraction, something really easy, and then go after those RAG or more complex applications next. And that's what we've done. And I think doing it in that order worked out a lot better for us than some of my peers that I talked to that have tried to do the reverse. I think a lot of people get stuck on that RAG project and spend a lot of, or waste a lot of time.
Okay, that makes sense. So in this is the extraction classification, but tell me a little bit about that retrieval process. So you did or didn't do a RAG approach to getting this information back out again for whoever needs that? What does it look like to the user now to be able to access all of these land documents that you would have put through the system?
So with this original project, the goal was to get that extracted data back into our land information systems. QLS is the Quorum Land system is the main database we use or system we use behind that. So once it's back in there, it's quite effortless for the folks in the land department to access that data and do automated analysis with that data. To your original question, which is what are we doing with RAG? What's the future for land in terms of are we doing anything with RAG? And Andrew could speak briefly to some stuff with Atlas, I guess. Yeah. I don't know if you want to touch on that.
I mean, so I think, like Alex was saying, we had very simple objectives early on, and now we're sort of exploring maybe what you might call the more interesting use cases, like a chatbot or talking to a document and getting some information out of it. And so we do have a couple applications for that. We've played around with Mongo's Atlas search index. I think Mongo just posted some GitHub examples of just like basically AI and Mongo. It's just some examples for people to follow along with. So we'll probably test some of those out and see how they do on some of our documents. But yeah, I guess I would say we're not sure what the future holds here, but we're going to try some of this stuff out.
Good. And look, thank you for that call out. Yes, we have a public repo called the Gen AI Showcase that a lot of the AI DevRel folks and indeed a lot of our engineers and product team have been creating examples and demos of how to build. Obviously, you're very familiar with vector search, but people would know MongoDB as a database company back in the day. And as you said, there was 2 years ago, there was dedicated vector databases. And, we brought vector search capability to MongoDB back in June of 23. And since then, we've been having great success being able to kind of participate in this Gen AI revolution that we see going on at the moment. But it was really good answer, because I had assumed that the retrieval portion of this bit was a RAG type thing. But exactly as you said, Alex and Andrew, so it was the extracting and the classifications that you then was powering the existing system that you already had in Oxy to make everything work. How hard was that to integrate with that I'm assuming an older existing system, right? But it was just getting the data in the shape that system needed automatically.
Yeah, it was extremely unpleasant, is what I'll say. A lot of these, I think, anybody, again, who's working with a lot of AI projects, a lot of times the worst part is just getting what you need out and back into these legacy systems, which oftentimes don't have like nice API layers for communicating in and out of them. It's more often like, just really clunky ways of getting data in and out. Just to continue my rant, I guess, against RAG, I think the natural instinct when looking at something like this would be to say like, let's do a RAG app where somebody can come and ask like, oh, what's the how many days do I have before this lease suffers from a cessation of production event, and the lease is canceled. That would be a really easy RAG example. You kind of ingest it all. You have some filtering that's like just regular database based, and some that's more like vector search based, but that whole way of doing it still requires a human in the loop to go to the chatbot and ask the question. Much, much better if we have an existing system, QLS in this case, where we can populate all the data properly and have some automated system working against that, which is effectively just a query or a scheduled task or scheduled process where you don't have to have a human come in and type that and remember to do that. So I think, increasingly where we're trying, like, if we need a human in the loop, we'll keep a human in the loop. But if we don't, let's just automate this and make it as easy as possible rather than having a chatbot where people have to go ask questions.
Okay, excellent. And which is a nice segue into, and you touched on this at the beginning, was, this project after the POC and then after, putting it across all the other, kind of taking it up to $1.5 million and beyond. What was the business impact for Oxy, and what was the return on investment? You had said there was going to potentially be 40 people doing a much smaller classification project. Tell us a little bit about how those numbers resonated within Oxy then, having done this project yourselves.
Yeah. So like you said, a couple million in savings by averting the manual classification effort. Got our answers 12 months sooner, because instead of 18 months, this was a 6-month effort.
Oh, wow. Okay. Wow. That's
so
quick.
Cost savings, time savings was big on this, but the larger thing is now that we're, this year we're looking at a lot of more sophisticated AI projects in land. And I think what this first project did is it really gave the wider company and land department especially a glimpse of what this tech can do. And it gave us, to be honest, an idea of what this tech can do. And I think it's really given us the license to go in and look at any process that's very repetitive, very manual, very unpleasant to do today. We're looking at automating large parts of those projects. And maybe in 8 months or so, we'll have something else we can share on the next iteration of this podcast about some of that. But I think we started simple, and I think now land knows and we know what's possible, and there's a lot more getting done.
Yeah, and as you touched on earlier, HR got wind of this and legal got wind of this. And as you said, this architecture with little or no changes was applicable to their use cases as well too. So obviously this is, spearheaded, given the cost and time savings, potentially lots of other projects and more work for you guys, right?
Yeah, for better or for worse, right?
Yeah, I had an old boss of mine who would say the reward for good work is more work, basically. And I think you two essentially exemplify that, right? You did it. It was a third of the time with only a few people, much, much less in cost. And now everybody else wants to use it, right?
That's right.
Excellent. So what advice, given this project, and I'm assuming given our audience is pretty varied, what advice would you have? You went in this from the POC saying, look, we got to test the OCR, we got to test the embeddings, we got to see, does this work? What advice would you have for companies or people in a similar situation looking to modernize, in this instance, their document management systems, but, modernize their applications and their database and using AI?
I can start. I'd probably mention two things, one of which Alex already talked on. So what Alex talked about, where it's much better to just do something than have to kind of have a hybrid solution of a human still has to interact with it, and now it's doing it. But like when you introduce tooling that basically forces a human to learn something else, that tooling usually faces some opposition. Whereas if you introduce some tooling that instead says, hey, you used to do this thing that you didn't enjoy, and now you just don't have to do that anymore. That's a much
People prefer that. Yeah.
That's
that's music to my ears, definitely.
That's a much better solution. Not like, hey, come check out this training for this new front end we built, and it'll make your life easier. Because like in that person's head, they're just thinking, well, this is one more training I have to do, one more thing I have to learn, something I still have to keep doing. And so one just philosophy I think our team has taken is, how can we just cut processes altogether? Let's not think about like necessarily enhancing it unless that enhancement means cutting work out completely. So that's one thing. And then the other thing I've seen on this team is I think we have a lot of people who are willing to wear a lot of different hats. And so we don't have like, a DBA who does all the Mongo work. And once the Mongo stuff feels good, we have a cloud engineer who does only cloud stuff. And then once that seems good, we have a DevOps guy. And so, it's everyone is doing everything. And yeah, different people have different strengths, and that's great to lean on that. But at the end of the day, I think most of the team could probably do this whole project start to finish. And that gives us a lot of flexibility on how quickly we can move, stuff we can get done. And so, yeah, that's been something that's really helped us out, is just people are willing to figure out how to do stuff in a fairly constrained environment, and with skills they didn't have before, but they're willing to go learn. So yeah, we were able to move really quickly on all this stuff.
Excellent. I think that's really good advice. Yeah.
The only other third piece of advice that I would add is kind of going on what Andrew said, is just try things. I mean, just experiment. I think the only way you learn what these models can and can't do is by experimenting with it. I think it's so new and it's changing so fast that you have to try things. I think we've had cases where some team comes to us with a problem and says, hey, can it do this? And we say, yeah, let's give it a try. We try it. And we say, yeah, it's kind of working, but I think to get it to the accuracy you need, this might take 6 weeks. And then we kind of leave it. And then 2 weeks later, a new model comes out. We try with a new model, and it just one-shots it, 100% accuracy, no extra work required on our side. So the only way you'll learn what these things can and can't do is just by experimenting, by trying it out. And it's a lot of fun. I think you just have to, like you kind of picked up on earlier, you have to de-risk, you have to do short POCs, you have to move fast. And like Andrew said, that the team design needs to be such that you're not having to have committees and multiple teams meetings and scrum cycles and stuff. None of that's going to work in this kind of fast-paced field. You just have to be able to move quick on a small team.
Okay. And on that, I suppose the new and the fast and how things are changing so quickly, either of you, what's the most exciting thing you're seeing now, even outside of Oxy, in terms of what AI is capable of doing? Is there anything that has you really excited and potentially you want to play around with even in your off hours, right? Not during the daytime, perhaps, as well too. What's exciting you most?
I'll say for me first, it's the reasoning models. I think we
Okay.
saw this, when we look at the big multimodal models, big language models, there was a scaling paradigm that got us to GPT-3, where we just had more and more data. We scaled up pre-training. We got these really huge and awesome models, but they weren't super applicable or useful yet. And then we saw the basically supervised fine-tuning feedback, or RLHF feedback, that got us to GPT 3.5, ChatGPT. And that was really, really exciting. And now we're kind of exiting those two regimes. Like, they're not to say they're fully exhausted, but we're kind of seeing the signs of exhaustion of those scaling regimes. And now we're moving to this reasoning-based scaling, which for any kind of verifiable domain like coding or mathematics or some fundamental sciences, I think it's really quite promising what's going to be possible with these reasoning models. I think for us, where we had seen some limitations on certain types of tasks that required, like, I'll give an example pertaining to land, which is a lot of the work we presented today was on single documents as a unit.
Right.
Like, we're having the language model classify and extract on a single document at a time. And where we saw struggling in the past with previous models is in cross-document reasoning. And I'll say with the new reasoning models, we're seeing a lot better results on cross-document work. And I think that's going to be a huge thing for this specific subject. But also for many, many other topics. I think these reasoning models are going to be very, very impactful.
Yeah, it's a good point. We've been playing around with, say, like the reasoning engine from Google, etc., as well too. And it's, I think that moves us into a new sphere, because, as you say, a lot of the applications are built. They're looking at a single source of truth, essentially. And in fact, as they grow and get bigger, is there anything, we hear agentic all the time now, anything in that space that excites you?
Definitely. I'm trying to think of what I can say specifically.
No worries.
But yeah, what I'll say is, for an agentic system to be successful, the standard for accuracy goes up a lot, because generally with agentic systems, you're seeing multiple steps, right? So you'd have, say instead of just an input output, you might instead have like a five step process, where if you're at 98% accuracy with each of those steps, well, you need to multiply 0.98 times 0.98 times 0.98, and then you're going to get maybe a much worse accuracy on the other side of that. So I'd say it's a much harder application to build an agentic system, but I think there's a ton of value there, and we're seeing a ton of value there.
Excellent.
I just wouldn't start there, I guess, is all I would say.
Yeah. Look, there's a lot of ways to go. And look, as you said, it's moving so fast and everything's so new. I think you're going to see frameworks for agentic come out to help you do that, because you need the safeguards in place, right? To make sure it doesn't go off a cliff at the other end if you've left it unmanned, as it were, to do its own reasoning and make its way through a number of stages, I suppose.
Yeah, and I'll say, kind of to that point, in oil and gas, we also need to be conscious about, we have to be picky about our applications. I think there's projects that we've looked at on our team, or we've been approached internally for projects where we really need to have a human in the loop. It's not safe to have an AI system doing something start to finish. With land document classification, I think the risks are a lot more limited. Maybe you're limited to financial risk, worst case scenario, if you mess something up. But yeah, certainly with things affecting equipment in the field, or safety operations, or personnel decisions in the field, I think we rightfully are acting a lot more cautiously, and I'd encourage others to act a lot more cautiously in those applications.
Sure. And in the same vein of everything moving new and fast, Andrew, how do you keep up with what's going on in the AI space? For example, is it blogs? Is it news feeds? Is it podcasts? How do you keep on top of things?
Yeah, for me, I mainly just listen to what people on my team are saying.
Okay.
But we've got some guys who are, we actually just had a guy who is basically scanning, archive.com, and that's Columbia University's site. Who's posting that?
I forget, but in any case, scanning for papers.
He's scanning through papers, sending out any interesting papers every week.
Okay.
so like he's kind of staying on top of it. Alex stays on top of it.
I'd say it's
pretty
like
well.
it's reading papers and,
Yeah.
and tech, ML Twitter, which you have to be kind of ruthless about curating your Twitter feed to keep it tech focused. But those are the two big sources for me is papers and Twitter.
Yeah, because there's an awful lot going on. There's as you said earlier, new things coming out all the time. There's a lot of leapfrogging. You think, oh, this is going to be the solution we need. And then you see something else that's easier.
Just today, Grok 3 came out. So now it's like, there goes my afternoon. I'm going to have to be testing the latest, the new model that looks to be a bit better than 4.0 for non-reasoning model. It's probably the strongest now. So it keeps it exciting. Just like you said, it's a lot of nights and weekends to stay on top of what's changing in this fast-moving field.
Excellent. Well, look, this has been fascinating, and it's an amazing to see. I suppose, look, I do this live stream an awful lot, and a lot of the time we've got demos and we've got some POCs, etc. But to see it in action, to see it at the scale that you've managed to do this in Oxy, to see the proof of concept borne out and to fruition, as in it was quicker, it didn't need 40 people, and we did it, and everybody else wants to leverage our architecture going forward as well too. Is brilliant to see. And you've explained your own processes internally really, really well. As we come to a close on the podcast, any last parting comments for our audience, or kind of words of wisdom, or things you've learned, or even looking back on this project, is there anything that you would have done differently, or anything that you really stumbled on, or everything super smoothly and no problems, do it all again the same way?
I think the only thing I would say is one thing I've really felt, especially just with the advent of these language models, has been having more of an understanding of a solution architect has been, I think, really helpful, because it's become so simple to dive deep into something you want to know how to do, but you do have to know what questions to ask, kind of. So I've found a lot of value, and it's kind of made me change my philosophy a little bit on learning going forward, is like, do you spend the time to become truly an expert at one thing, or can you get a lot more value from sort of knowing a whole lot of different things and how they work together, more of like a system design instead of, deep SME on whatever it might be. And so I think there's a balance there. But yeah, I've really felt lately that just knowing how systems work and seeing how they should be built, it's become a lot easier to actually go build the system. But kind of understanding the edge cases, what to watch out for, where things go wrong, all that stuff you really do have to have a good understanding of, where things will go very wrong. But building has become much simpler than it used to in the past. So I don't know. I'm still trying to figure that one out myself, but I'm exploring it.
And Alex, anything to add to that?
Yeah, I'll just say, if there's one thing on my wish list for 2025, and I intend to do a better job at this, I want to see more open source work in oil and gas. I think there's a few companies that are doing a really good job at this, but that's my call to action for everybody listening, and also just for me personally. I think we need to share more. I think it's exciting to see what other people are building. So I hope to see more of that this year.
Yeah, look, I'm a big fan. It's always great to learn from other people and to see what they're building, and to have that shared experience and that sense of community, I suppose, as well too. That as you say, large companies, sometimes that's hard to foster, right? But I think everybody is trying to solve not much the same problem, but architecturally much the same problem, and we could all learn from the collected. Perfect. Well, look, this has been super informative. I've learned a lot, as I always do. It's the reason why I do these podcasts, is for my own education as well too. But Andrew and Alex, you've made it incredibly clear to follow the pathway, and as I said earlier, a really good example of taking that, understanding that inclination that I think we can do this in a different way, and then into the POC, and then into the actual production, and to take I suppose that drudgery out of that classification and extracting, and to help the collective team there and go, look, It's all in your system. Work away as you always did, but it's now just easier. So I think that's a brilliant example. And very much, I think you alluded to, Alex, there might be something in the future. So as soon as you build something new and different, hopefully with a bit of MongoDB in the background there as well too, we'll certainly get you back on the podcast to show it again as well too. But Alex, Andrew, thank you so much for your time. We do appreciate it. Thank you for everybody who joined us as well too. This is great. And as I said at the intros, do keep up to date with what we're doing on these shows by liking and subscribing on our YouTube channel and following us on LinkedIn. You will be able to keep up to date with future episodes like this. And if you want to keep up to date with, our examples that we mentioned earlier and other case studies, etc. as well too, just go to developer.mongodb.com. You'll find everything that our DevRel team and others with inside MongoDB create and build. And if you're not already using MongoDB, but you'd like to get started, we have a load of help. We've got a great forum. We've got a great community where all our users hang out, and obviously our engineers and our DevRel team and our product managers as well too. So community@mongodb.com. That's the end of my plugs. Any parting words, Andrew or Alex?
Thanks for having us.
Yeah, thanks a lot, Shane. A lot of fun.
No, listen, you made my job super easy. It's been a pleasure to host you both. And I look forward to see what you build in the future. But for now, thank you so much. It's been a pleasure. Take care, everybody. Andrew, Alex, thank you.
Thanks.